Hello, welcome back for a brand new unit in Algebra 2. This is Unit 6, and Unit 6 is all about quadratic functions. In Unit 5, we studied quadratic expressions and quadratic equations. We learned how to solve them by completing the square, factoring, using square roots in the quadratic formula. So we'll be able to apply a lot of what we learned in that unit as we look at functions that are quadratic in this unit. This first lesson is about quadratic functions in the standard form. So be aware that we'll be looking at several different forms that a quadratic function can take. All right. I think you can probably guess what goes in these blanks here, right? A quadratic function is a function that can be put in the form of y equals ax squared plus bx plus c, where a does not equal 0. So this is basically the same definition that we had for a quadratic expression, except for now we have y equals, making it a function. The zeros of a function f of x are any x values which make f of x equal to 0. So a 0 is a number. Quite often that 0 is not, in fact, the number 0. It's a number like 3 or 4. And when we put it in, so we have x, okay, and then we have a function f, which maps x to f of x, right? Well, if we put in a number like, say, 7, and f maps 7 over to 0, then because 7 that went into the function and 0 came out, we call this number here a 0 of f. Okay? All right. So we'll be talking a lot about that as well. All right, we're going to represent the following quadratic function using a table of values in a graph. We'll identify the zeros, the domain, and the range, and something called the vertex. All right, so our function is f of x is equal to x squared. So we need to be plugging in these numbers for x. So this will show the process here. Let's figure out what f of negative 3 is. Well, we're going to put a negative 3 in parentheses. Very important that we plug that in. Otherwise, we wouldn't square the negative. We'd only square the 3. So that makes this 9. So this is 9. Then we can do f of negative 2. Negative 2 squared is 4. F of negative 1. Negative 1 squared is 1. F of 0 is 0. F of 1, that's just 0. F of 1, we need to plug in 1, right? I can use parentheses if I want. Wouldn't be wrong, but I don't need to because it's a positive number, so that's just a 1. F of 2, 2 squared is 4. And then f of 3, 3 squared is 9. So negative 3 goes to 9, which is way up there, and I don't actually have room for it. Negative 2 goes to 4. Negative 1 goes to 1. 0 goes to 0. 1 goes to 1. And 2 goes to 4. And then, like we said, 3 went way up there to 9. So if we were to draw this shape, we get the famous parabola. You know, I'm sure you've heard that name before. This is the shape that we see when we shoot a basketball at the hoop. But of course, it's the other direction, upside down. All right, the vertex of a parabola is the point where it stops going down and starts going up. Or it stops going up and starts going down. It's just where it changes direction. It turns. That's the vertex, okay? So we'll find that the vertex of this parabola is the point 0, 0. Well, what are the zeros of this function? Well, typically quadratic functions are functions that have 2 zeros. Sometimes they have no zeros, and sometimes they have only one. Just like quadratic equations have solutions that are either two solutions, one solution, or none. This one has exactly 1, 0 because it touches the x-axis at exactly 1 point. So, or another way of thinking about that is that the x value 0 when plugged into f gave us 0 for an output. So the only 0 is the number 0. So now we've got a few different ways to talk about how to find zeros. We can look at the graph and see that the 0 is the place where we touch the x-axis, which in this case is also the location of the vertex. We could talk about it's where the f of x gives you 0 when you plug it in, or it's the x value that makes 0 appear in a table. All right, well, let's talk about the domain. To find domain, we're looking for values of x that we need to exclude. So typically our domain is all real numbers. That's the domain in our Algebra 2 class, unless one of those numbers would cause us to divide by 0 or square root a negative number, because those are things that are not allowed to be done, right? Well, in the equation x squared, there's no division by 0. There's no square rooting. There's no number that is not allowed. So we're going to say the domain is all real numbers. And you can say, double strike R. You could say all real numbers. You could say negative infinity to infinity, which is actually usually the way I prefer, but I don't always do that. And then range. Well, range is the set of y values that the function maps. The range is interesting here because when we square a number, as long as we plug it in parentheses, any of these numbers squared always ended up being positive, except for 0. So all of our values are 0 and up. There's no way to get negative numbers. So we have a smallest value of our range 0 and a largest value approaching infinity. And there we have it. We've got the zeros, the domain, the range, and the vertex. All right, well, what I'd like you to do is practice with a different function. This was our parent function. So we'll be looking at some transformations of that in the future. I'd like you to look at another version of a simple quadratic equation. In this practice problem, I want you to fill in the table, identify the zeros, domain, range, vertex, and graph it. All right, well, let's see how we did. We're plugging in -3 here. So f of -3 is equal to, we have a negative on the outside, and then this -3 here, and then we square it. So we need to square the -3 first. Squaring comes before multiplication. So this -3 became a +9, but this negative here, this negative is still there, okay? But this negative got squared to become a 9. So it's -9. Let's take a look at f of -2. Well, it's going to be the same thing. We have a negative on the outside and then this negative here. Well, that's going to become a -4. And this will be a -1, a 0. And then let's look down at this one, f of 1. Well, we have the negative on the outside, but the squaring only goes to the 1. If you don't put in parentheses, you don't have to put a positive number in parentheses when you substitute in. Just put the 1 and then square it. Well, we've learned that this squared, when there's no parentheses, only goes to this number. Whether I put parentheses around it or not, that squared is only on that number because the negative is a multiplication and exponents come first. So this is still a negative. That negative comes along. 1 squared is 1. So the answer is a -1. Likewise, this will be a -4 and a -9. If you didn't get a parabola shape, you probably messed up on the rules of negatives. All right, let's plot the values. -3, -9 is way down there. -2, -4, right? -1, -1. 0, 0. 1, -1. 2, -4. So we get something like that, and something like that. Okay, so we have a vertex at 0, 0 again. we have 1, 0 in this problem. Once again, just 1, 0 at 0. Notice I'm putting set notation for my zeros. It's a set. We have, let's see here, what's our domain? Our domain is negative infinity to infinity. And our range is different than we had before. It's negative infinity up to 0. Or maybe you said y less than or equal to 0. Okay? Okay, so we have a formula. The x-coordinate of the vertex of a quadratic function, f of x equals ax squared plus bx plus c, can be found using the formula negative b over 2a. You might recognize that as being straight from the quadratic formula, but without that pesky plus or minus b squared minus 4ac. So it's just negative b over 2a. Finding the vertex is going to make it a lot easier for us to graph when we get more complicated equations. So here we go. Let's do this. We're going to sketch the following function. We're going to identify the zeros, the domain, the range, the vertex, and something called the axis of symmetry. So we'll talk about that as well. All right, I'm going to start with finding the zeros. Instead of generating a table of values, though, I'm going to solve for them algebraically. A 0 is a value of x that makes f of x output the 0. So I'm looking for a number that when I put it in here for x gives me 0. Well, we learned how to do this in the previous unit. We can try factoring, and this factors like so. Then if I set each factor equal to 0, I can solve this fairly easily. All right, so there we have it. We have zeros, 3 and 1. Well, what does that tell me about the graph? Well, we know that the zeros correspond to where this graph crosses the x-axis at 3 and 1. The vertex can be found using to find the x-coordinate of the vertex, we can use negative b over 2a. So x equals negative b over 2a. So that is a negative of a negative 4. So opposite of 4 is negative 4 is 4 over 2 times 1. That's 4 over 2 is 2. So we know the x-coordinate of the vertex is 2. Well, what do we find? How do we find the y-coordinate? We plug it in. Let's find out what f of 2 is. That'd be 2 squared minus 4 times 2 plus 3. 4 minus 8 plus 3 is a negative 1. So 2 comma negative 1 is my vertex. Let me label that over here. When I ask about the axis of symmetry, do you notice how this vertex is right in between the two x-intercepts? Well, that's always going to happen because parabolas are always symmetrical across a vertical axis of symmetry. That's what that's called, the axis of symmetry. So we're gonna call it axis of symmetry, and it's a vertical line. Vertical lines are always of the form x equals, and it's x equals 2, which we got earlier. So when we did this, we weren't just getting the x-coordinate of the vertex, we were getting the equation for the axis of symmetry, which has to go right through the vertex. All right, well, you know what? Let's find out what the y-intercept of this equation would be. That's an easy number to plug in, right? So I want to find out what f of 0 is. Here, I'll put it over here. Well, if I plug in 0 for x, I get 0 squared is 0 minus 4 times 0 is 0 plus 3. It's just 3. Well, how does that help me? Well, look at the axis of symmetry. See how this point is 2 to the left of it? Then wouldn't you agree that there must be some other point 2 to the right? And this is really a pretty good set of points to graph. In fact, it's just as many as we got on the previous example that fit in the space I gave you. And as is typically the case in my class, I'm more interested in the sketch and the important information than I am a point perfect graph. Last thing we need to do is identify the domain and range. So the domain of this function is negative infinity to infinity. Graphically, you can see the domain is that because it goes forever left and right. These bars will continue, this graph will continue to get wider and wider. And the range, it has a lowest value at negative 1 and goes up from there. And we also know that the domain is negative infinity to infinity because we know that that's our default domain unless there is like a divide by x or a square root, something like that. Okay, let's move on. I got a practice problem for you to do. I'd like you to identify the zeros, the domain, the range, the vertex, and the axis of symmetry. Give it your best shot, and let's see how you do. Okay, let's see what happens. First of all, let's find the zeros. I'm going to plug in 0 for y of x. Don't get me confused by y of x. It's just kind of like saying f of x, but we are using the letter y because y is a function of x. So we have x, let's see here, plus 5 if I factor this, and x plus 1. Well, then that's going to give me, let's see here, x plus 5 equals 0. So x equals negative 5. X plus 1 is equal to 0. It's going to be x equals negative 1. So negative 5 and negative 1. So this axis of symmetry must be somewhere in between here. Wouldn't you bet that this is going to be like at negative 3? We can confirm that using our axis of symmetry, our vertex formula. It's negative b divided by 2a. So that's a negative 6 over 2 times 1. So negative 3. That's the axis of symmetry. I'll just label that right quick. Okay, and we found some zeros earlier. And those zeros corresponded to x-intercepts, right? So we had 2 zeros, so we had 2 x-intercepts. All right, what next? The vertex. We got the x-coordinate. Let's get the y-coordinate. So if you have the x-coordinate of the vertex, plug it in to get the y-coordinate. This is 9 minus 18 plus 5. That's a negative 9 plus 5 is a negative 4. So right there. All right, what else can we say? Well, do you know what it would be if I plug in 0 for x? Y of 0 would be 0 squared plus 6 times 0 is 0 plus 5. And then since we know that this is the axis of symmetry at x equals negative 3, can we use that to help us get another point? You betcha. 1, 2, 3 away, 1, 2, 3 away. And I think we can do this. Now, there's one more point I'd like us to show. This is the point right here. One step away, as long as the number in front of x squared is a 1, will either be up 1 over 1 or down 1 over 1. That's only true one away. It's going to be right through there. We saw that with the earlier parent function and then the negative of it. Now, once this becomes a different number, then that's going to be a different value that it goes through, though. Okay, so that's another one in the books almost. We got to get domain and range. Domain, I'll just call it D. I think we know what that's going to be. And the range is got a lowest point at negative 4 and a top point approaching infinity. All right. Okay, got another problem. We're going to identify the zeros, domain, range, and vertex. Let's get the zeros. To get the zeros, we're looking for when f of x equals 0. So we'll just solve this equation. All right. Let's see. Is that factorable? I'm not sure that is. We better use the quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right. So that's 8 plus or minus the square root of 64 minus 40 is 24 over 4. Okay, so we can break down 24. That's 8 and 3, which is 2 and 4, which is 2 and 2. So we got a pair of 2's. So it's 8 plus or minus 2 root 3 all over 4. Now, I can actually reduce this a little bit. Because I can reduce each one of these numbers by 2. That becomes a 4, a 1, and a 2. So as long as you can do all three of those numbers and don't touch this number in the radical, then we can say our zeros are 4 plus the square root of 3 over 2, 4 minus the square root of 3 over 2. Okay. Let's find the vertex. The vertex, I'll work that over here. The vertex is got an x-coordinate at negative b, so negative 8 over 2a. That's this part right here. You see that? That 8 over 4 part. And that's you can see it here that we're symmetrical. This 4 divided by 2 is 2. This is 2, and then, we have to move right and left root 3 over 2. So that's going to be equal to a 2. Well, what is f of 2? F of 2 is 2 times 2 squared minus 8 times 2 plus 5. That's 4 times 2 is 8 minus 16 plus 5. I get, let's see here, negative 8 plus 5 is a negative 3. So my vertex is 2, negative 3. Let's start plotting some points. 2, negative 3. We've got a y-intercept at 5, because if you put 0 in for x, you get 0 minus 0 plus 5. Once again, we know that the axis of symmetry goes right through the vertex. That's going to help out as well. 1, 2, right? Okay. And because this number is a 2, instead of going through this point, it's actually going to go up a couple from there. It's going to go up 2 when it goes to right. So our curve is going to look something like this. And notice that we didn't get an x-intercept that goes right through a lattice point, right? It doesn't go right through a grid. Kind of goes off a little bit to the side. And that's because, we didn't get rational zeros. We got irrational zeros. But now you have kind of a picture of it. This value here, this is 4 plus the square root of 3 over 2. This value here is 4 minus the square root of 3 over 2 on a number line. All right, domain. Domain is negative infinity to infinity. Range is negative 3 to infinity. And there we have it. All right, we have another one. It's not even your turn yet. Okay, I get to do another one. All right, let's try this one. All right, let's find the zeros of this one. 0 is equal to negative x squared plus x plus 6. I don't like that negative there, so I'm going to divide every term by negative. 0 divided by negative 1 is still just 0. So x squared minus x minus 6. I wonder if we can't factor this one. I think we can. X minus 3, x plus 2. So that's going to give me x equals 3, and that's going to give me x equals negative 2. All right. So we have negative 2 and 3. Now let's find where would the vertex be? Well, the vertex is going to have to be halfway in between there. So it's going to be at x equals negative b, so negative 1 over 2a, 2 times negative 1. That's going to be a negative 1 over negative 2, which is a positive 1/2. Oh, yuck, right? Why did that happen? Well, you can see from the zeros, this is the point that would be halfway in between them, 2.5 away from each one. So we're going to have to deal with that. Let's find y of 1/2. So it's a negative 1/2 squared plus 1/2 plus 6. So that's a negative. Square the top, square the bottom. You square a fraction by squaring the top, square the bottom. 1 squared is 1, 2 squared is 4, so it's a negative 1/4 plus a 1/2 plus 6. We can get common denominators for each one of those. Multiply by 2 over 2. And multiply by 4 over 4. So you can see that that's just 25 over 4, which is 6 1/4. So right about there. Just perfectly had enough room, right? Y-intercept is plug in 0 for x. 0 plus 6. Okay, plus, oh, you know what I did wrong? I put that in the wrong place. That's a positive 25. I'm going to say that's not 6, that's positive 6. I'm thinking me negative. It should be up here at 25 fourths. There we go. Then 6, which means this is also a point on the curve. All right, so I think we can kind of see what's going on here. It's going like that. It's moving down. All right, well, hopefully you didn't find that one too tedious. Domain is negative infinity to infinity. And the range here, be careful, it's going down. So we put negative infinity up to 25 fourths. All right. All right, what I'd like you to do is sketch this one. I want you to identify the zeros, domain, range, and vertex. Give it your best try. All right, you ready to go over it? Let's find the zeros. Well, you know, there's a common factor in each one of these. Divide through by -2. That gives me 0 divided by -2 is still 0. That's x squared minus 4x minus 3. I think that's right. Yeah. Now, can we factor that? No, I don't think so. So we'll have to use quadratic formula. X is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a. So 2 times 1. So that's 4 plus or minus the square root of 16 plus 12 is 28 over 2. So 28 is a 7 and a 4, which is a 2 and a 2. So I can pull out a 2. So it's 4 plus or minus 2 root 7 over 2. And because I can divide each one of these numbers by 2, this becomes 2 plus or minus the square root of 7. So my zeros are 2 plus the square root of 7 and 2 minus the square root of 7. Let's see if we can't plot those. Wait, we can't because they're not rational numbers. Well, you can think about it, though. We know that 2 plus the square root of 7 is square root of 7 is between 2 and 3. So this is about 4, in between 4 and 5. So it's going to be somewhere over here. And then 2 minus a number between 2 and 3 is going to be somewhere over here. Let's get the vertex and axis of symmetry, though. So the axis of symmetry, or the x-coordinate of the vertex, same thing, is negative b over 2a. Should be a 2, right? Because we have 2 plus a number, 2 minus a number. 2 is right in the middle of it. We'll just double check. Negative 8 over 2 times the negative 2 becomes negative 8 over negative 4. So it's 2. So that right there, that is the value of that is the equation for the axis of symmetry. What is the y-coordinate? Well, we have to plug it in. Let's find out. F of 2 is negative 2 times 2 squared plus 8 times 2, and I'm running out of room, plus 6. So that's 2 squared is 4 times the negative 2 is a negative 8 plus 16, and then plus 6. So that's 8 plus 6 is 14. Oh, I see why I made the graph so tall. All right, so we got 14. All right. Let's see here. Can we find a y-intercept? If I plug in a 0 for x, I would get 0 plus 0 plus 6. Okay, I know that's got to be 2 away over here as well. We talked about how this number here tells you 1 away, how far it moves down. It's going to go down 2, not just down 1. And we said that the x-intercept is somewhere in this interval here and then somewhere over here. And that looks to be exactly what we're getting because we saw that when we did the zeros. So, yeah, not a lattice point, not a perfect little number, but an irrational number, but still a real number. Okay, and the domain, what is that? Negative infinity to infinity again. And the range, what is that? Looks like we come from negative infinity, go all the way up to 14 with the bracket. All right. Got another one for you to do. So if you haven't already, pause the video and do this one. All right, let's go over how we would do this one. We have x squared plus 2x minus 6. I don't think that's going to be factorable, so we'll have to just do the quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So this is negative 2 plus or minus the square root of 4. That's minus 4 times 1. So that's minus times minus going to be a plus. That's 4 plus 24. So this is negative 2 plus or minus the square root of 28 over 2. Hey, we've seen this before. 28 is 7 times 4, which is 2 times 2. So I get to pull out a 2. So this is going to be negative 1 plus or minus the square root of 7. What about the axis of symmetry? Those are the zeros. Those are the zeros. But what about the axis of symmetry? Well, we know that's going to be at x equals negative b over 2a. So negative 2 over 2 is negative 1, which is not surprising because our zeros are at negative 1 plus root 7, negative 1 minus root 7. So negative 1 must be halfway in between them. So that's my axis of symmetry. Let's plot some points. Oh, but we haven't got the vertex yet. We got the x-coordinate, we've got the vertex. What's y of negative 1? Well, it would be negative 1 squared plus 2 times negative 1 minus 6. So that's 1 minus 2 minus 6, negative 7. Oh, no. It doesn't quite fit, does it? Arg. Oh, well. Y-intercept is 0. Plug in a 0 for x, you get negative 6. You can flip it over the axis of symmetry there. And it comes right about there. We know that the x-intercepts are, square root of 7 is in between 2 and 3. So negative 1 plus 1, 2 is somewhere in between 2 and 3, somewhere there. So let's just go with that. We could plot a few more points if we really wanted to. Let's see, we have 1, 2, 1, 2, somewhere in between here. All right. That's the end of that one. Domain is negative infinity to infinity. And the range is negative 7 up to infinity. All right, let's try this one. First, we get the zeros. Okay, anytime you don't have a constant, anytime every term has an x, that means that 0 is a 0. It means you can factor out an x. So let's factor out an x. I get negative x plus 4. So one of my factors is found by setting x equal to 0. One of my zeros. Set this factor of x equal to 0. Then I have negative x plus 4 equals 0. So I get 4 equals x. So 0 and 4. Those are my zeros. Finally got some that we could find by factoring, huh? So it looks like the axis of symmetry has got to be right in between there. It's x equals negative b over 2a. So that'd be a negative 4 over a negative 2. That's a positive 2. So that's good. That's what we thought would happen. F of 2 is negative 2 squared plus 4 times 2. That's a negative 4 plus 8 is 4. Would make sense that my vertex be up here. Since this is negative, it's going to go downward. So 2, 4. Well, y-intercept, we already found that. That was 0. Okay. Negative 1. So I said it would go down 1 over 1. And so we got something like that, with a domain of negative infinity to infinity and a range of negative infinity to 4. All right. All right, got kind of a nice little exit ticket. I know I don't always go over these with you in the videos, but this one's nice. I have a graph of negative x squared plus 4x plus 5. Here's the graph that you're looking at. I want you to use the graph to identify the zeros of the function and the vertex. So just pretend you're looking at the graph. You have to find the zeros and the vertex. But I want you to confirm it algebraically. So first get what you expect to be the answer, and then confirm that it's true. All right. Well, hopefully you did that. If you haven't, please pause the video and do it. I don't usually go over your exit tickets, but I think this one is just worthwhile that we do it because, the exit ticket is for you to know if you've gotten what I'm trying to get you to understand. If you're picking up everything I'm throwing down. All right. Well, I think from the graph, it looks like the vertex is at 2, 9. So how can we confirm that? Well, we've learned that the formula for the x coordinate is negative b over 2a. It's just that front part of the quadratic formula. So negative b would be negative 4 over 2 times a negative 1. That's a negative 4 over negative 2, which is 2. Okay? Well, what is f of 2? Negative 2 squared plus 4 times 2 plus 5. So when you plug in that 2, you didn't have to put it in parentheses, but I want you to understand that the exponent goes there. This negative on the outside means that these numbers will be negative. So this is a negative 4, then plus 8, and then plus 5. So that's 9. So 2, 9 is what we get, and that's what we said we would get. What about the zeros? Well, the zeros appear to be negative 1 and 5. Can we confirm that? Well, if they are indeed those whole numbers, this stuff must be factorable. All right, I don't know about you, but I don't like factoring with that nasty little negative there. I'm going to divide by negative 1, which changes all the signs. Then I'll factor. Make that x minus 5 and x plus 1. I'll set each factor equal to 0. And I get x equals positive 5 and x equals negative 1. So those are the zeros. Just like we said. But sometimes graphs can be deceiving. Sometimes what looks to be integer values are in fact just decimal values really close to that number. So that's why it's good to have an algebraic way to do things. All right, well, that's it for this lesson. Hope that made sense, and I'll see you in the next one.